Here we are in section 2-2 exercises numbers 4 through 9. We're reviewing some arithmetic with scientific notation, and let's remind ourselves of a few of the key points. We can change the exponents. If we move the decimal left, it will move the exponent up. Decimal left, left up. It's left up to you. If we're adding or subtracting, we must get common exponents and they won't change. In multiplication, however, we do add the exponents, but we don't have to get common exponents. So that'll help us through these problems. So the first one, this is 2.3 times 10 to the negative 10 plus 7.9 times 10 to the negative 11. We need to make these two the same. So if we're going to do this left up, notice that negative 10 is bigger than this one. So if we move this 7.9 to the left, and make this up 1, that will go to a negative 10. We have 2.3 times 10 to the negative 10. And then this one is now 0.79 times 10 to the negative 10. We moved it left and we changed that up so they now have common exponents. So now let's add them. 0 plus 9 is 9. 3 plus 7 is 10. Carry the 1. 1 plus 2 is 3, so that's 3.09, and times 10 to the negative 10. Again, once these are the same, they stay exactly the same. So 3.09 times 10 to the negative 10. Okay, next one. Number 5. This is subtraction, so again, we need common exponents. Oh, look, we have them. So this is 9.5 times 10 to the 7th minus 8.1 times 10 to the 7th. They are already like exponents, so we can just subtract them like normally. 5 minus 1 is 4. 9 minus 8 is 1. This is 1.4 times 10 to the 7th power. Excellent. Number 6. Multiplication. We do not need to make that 6 a 12 or make that 12 a 6. So we have 2.5 times 10 to the 12th times 2.5 times 10 to the 6th. We just multiply these. 5 times 5 is 25. There's a 5. Carry the 2. 5 times 2 is 10. Plus 2 is 12. And then we put a 0 here. 2 times 5 is 10. 0. Carry the 1. 2 times 2 is 4. Plus 1 is 5. So add this up and we now get 625. How many decimals do we have here? 1 behind the decimal, 1 behind the decimal. So we get 6.25 times 10 to the, remember what we do here? Add these exponents. Yep, so that becomes 18. 6.25 times 10 to the 18th power. Excellent. Number 7. We're adding, so we've got to get common exponents. Okay, let me see. This is a 6, and that's a 4. Let's move this one up 2. So we've got to go up 2. So that means this decimal that's right after the 9 has to go 1, 2. So it is 4.351 times 10 to the 6th plus, and now this is going to be 0.009. Nope, it's just 0.09. 0.09 times 10 to the 6th. Now make sure you see all that we went left and that went up 2, left 2, up 2. All right, so that stays the same. That's going to be times 10 to the 6th. And this is going to be 1 minus 0 is 1. 5 minus 9, can't do that. Borrow. 15 minus 9 is 6. 2 minus 0 is 2. Decimal point straight down, and a 4. 4.261 times 10 to the 6th power. Okay, next one, number 8. 4.3 times 10 to the 12th times 9.2 times 10 to the negative 5th. We're in multiplication, so we'll be adding the exponents, and we do not need to get them the same. So let's put that up. 4.3 times 10 to the 12th times 9.2 times 10 to the negative 5th power. Okay, so when we times these, now we could do these exponents first. This will be times 10 to the 7th power will come out there. 12 plus a negative 5 turns out to be a 7. Okay, now let's multiply the decimals. 2 times 3 is 6. 2 times 4 is 8. Good. Put a 0 down for the next level. 9 times 3 is 27. That's a 7 there, and carry the 2. 9 times 4 is 36, plus 2 is a 38. Add these guys, and we get 6, 5, carry the 1. So that's a 15, 9, 3. Now, how many decimal places do we have? 1, 2. So this is this. So we have this problem right here, 39.56 times 10 to the 7th. This is the correct answer. However, it's not in scientific notation form right yet. Where does the decimal have to be for scientific notation? It has to be moved over one place to put it right here. So that's the right answer. So when we move this over, we've got to have left, up. So we move it there and we get 3.956 times 10 to the 8th power. That's in simplified form. This is the same number as 39.56 times 10 to the 7th, but now it is in official scientific notation form. Okay, next one. Number 9. This is a subtraction problem, so we must get common exponents. Let me see. We'd have to move that down 1 to get to -5, or we could move this up 1. So that's how we're going to do it. Move this guy to the left. So we get 3.57 times 10 to the -4th power minus 0.1. Note that the decimal moved 0.1 times 10 to the -4th. So we moved the decimal, so we would have like exponents. 7 minus 0 is 7. 5 minus 1 is 4. 3 minus 0 is 3. Decimal comes straight down, 3.47 times 10 to the -4th power. And there we have it. Good.